Hello, this is Mr. Drach, and we're going to be talking about balancing reactions or balancing equations today. You can't really start a stoichiometry problem or anything in stoichiometry without balancing the equation first. If you notice in the picture up above, we have a balanced reaction of copper and oxygen combining to form copper 2 oxide. If you notice on both sides of the arrow, we've got 2 copper atoms, 2 oxygen atoms. And that's what a balanced reaction is, the equal number of atoms on both sides of the arrow. That's really what we're trying to do. We're going to start off with a very simple equation. In this case, we have hydrogen and oxygen combining to form water. And it looks like a simple equation. It's kind of a neat equation, a very explosive equation, which we'll do in class one of these days. And if you notice, we've got, over on the left side, we've got 2 hydrogens. If you notice, they're down here. It's a diatomic hydrogen. We also have 2 oxygens. Down here, we've got 2 oxygens, our diatomic oxygen. Okay. Now, on the other side of the arrow, we've got 2 hydrogens, but we only have 1 oxygen. Okay, so that's not balanced, and that's not very good. The reason why is it does not follow LOCOM. If you remember that from the first semester, that means the law of conservation of mass. Okay, atoms cannot be created or destroyed. Mass cannot be created or destroyed. Okay, so we can't start with 2 oxygens and only end up with 1. So we have to kind of solve that. Now, we could do a couple of things incorrectly. One incorrect thing would be to add a little 2 over here. Now that's no good, because now we change water into a totally different substance. That's hydrogen peroxide. We can't do that. Okay, we can't just change our substance, so that's not how we're going to balance it. It's also been suggested that how about we just add another O? Again, that's no good either. We never have an O by itself. It's always diatomic when it's by itself, so I can't just add another O here. Okay, so I really cannot change any of those numbers that I start off with. The only thing I can do is add something called coefficients. Coefficients are just like in math. We can put a number in front of something to multiply it. Okay, so I could put a number there, a coefficient. I could put a coefficient there. I could put a coefficient there. Okay, and those coefficients again are going to multiply whatever's behind it, because I want one side of the reaction to equal the other side of the reaction. Okay, if you notice, our oxygens are not balanced, so we're going to have to multiply, and we're going to multiply the right side by 2. Okay, if we multiply the right side by 2, that multiplies everything behind it. Okay, if it's not separated by a plus sign or an arrow or something else. Now, we don't really write these lines or parentheses, but it will multiply so that now I've got not 2 hydrogens, but 4 hydrogens. Not 1 oxygen, but now I've got 2 oxygens. Okay, now I've got to go back over to the left side because now my hydrogens are not balanced. I've got 4 hydrogens, and I need to multiply that to get 4, so I'm going to put a 2 over here. Okay, and I've only got 1 oxygen right here. Now, normally we do not write a 1 in chemistry. We might ask you to write that on a quiz, but just know that there is kind of a 1 right here. But again, we just don't show that. Okay, so now we've got a balanced equation. So the big 2, our coefficient over here, multiplies this. Our 1 kind of multiplies this, and our 2 multiplies that. Okay, just like in math, those are coefficients, and we want one side equal to the other. Here's what a balanced equation looks like. Okay, again, notice I've got my 4 hydrogen atoms. I've got my 2 oxygen atoms, and I've got my 2 water molecules. Okay, and what we have here is 1, 2, 3, 4 hydrogens and 2 oxygens. Okay, so I've got my 2 oxygens and 4 hydrogens. So that's a balanced equation. Now, what's conserved in this, what I mean is what's equal on both sides of the arrow are a couple of things. Okay, if you notice, I have the exact same amount of atoms. Okay, so atoms are conserved. They're always conserved. We always have equal number of atoms on both sides. The other thing that is conserved is mass. We're going to add those up, and if we did, we can kind of see that we have the exact same amount of grams on each side. Okay, so mass and grams are also conserved. That's a big deal. We're going to practice balancing a couple of equations now. Okay, but before we do that, just a couple of tips for balancing these equations, reactions. One, you want to use a pencil because you will mess up and you're going to have to kind of go back and try again. Number two, do not ever change the formulas. The little small numbers like H2O, we can't change that little 2. Pretend there are blanks in front of each separate element or compound. We're going to fill in those blanks. That's really all we're going to do those. Just add some coefficients on those blanks. Helps out if you balance the easiest thing first, and usually the equation just kind of works itself out. And lastly, coefficients must be in the lowest whole number ratio. Okay, if you notice the reaction down here, I can divide everything by 2, right? Okay, so this equation is incorrect because I can divide everything and get a ratio of 2 to 1 to 2. Okay, so it's always got to be in the lowest whole number ratio. We're going to practice a few. What I'd like you to do is go ahead and write that in your notes. While you're doing that, NH3, that's ammonia. We're going to see that a lot this semester. Okay, so we're going to go ahead and balance that. Again, all we're doing is writing numbers on blanks in front of each element or compound. And again, those are called coefficients. Now, balance the easy ones first. If you notice, I've got 2 nitrogens right there. So I might need 2 nitrogens over here. And that 2 multiplies that whole thing. So now I've got 2 nitrogens. And I've got 6 hydrogens over on that side of the arrow. Okay. Over on this side, I need to get the same. Now I've already got 2 nitrogens. And I need to get 6 hydrogens. So how to do that? I'm going to put a 3 right there. That 3 multiplies this H2. So I'm going to get 6 hydrogen, and that's balanced. 2 nitrogen, 6 hydrogen. Put that 3 back there. And again, we usually don't keep those blanks in there. So that is a balanced chemical equation. Okay, let's try another one. Here I've got carbon and oxygen combining. And by the way, that last one, that's a decomposition. Here we have a combination of carbon and oxygen going to carbon dioxide. Now, if you notice, I've got 1 carbon over on that side. I've got 2 oxygen over there. Over here, I've got 1 carbon and 2 oxygen. If you notice, this one is already balanced. And if it's already balanced, we can just leave it alone. We're done. Okay, we don't want to put any numbers in front of there. All right. If you did put, like, say, 2, 2, 2, you know that's not in a lowest whole number ratio. Okay, so that one's already balanced, and sometimes that happens. Don't have to do anything. Okay. Our last reaction is this one. This is a single replacement. I'll give you a second to write that down. We have aluminum and sodium sulfide reacting to give aluminum sulfide and sodium. Okay, it's a single replacement because our metal is replacing the other metal, kind of stepping in on the dancing partner. We're going to try to balance this. Again, start with the easiest one first. If you notice, I've got, for sodium, I've got 2, so I might put a 2 over here. So now I've got 2 sodium on each side. Okay. Let's start with the next one. Sulfur. For sulfur, I've got 3 over here. So I might need a 3, multiply this. But when I put my 3 over there, it multiplies everything. So it multiplies my sodium. So now I don't have 2 sodium, I've got 6 sodium. Okay. This is why we use a pencil when we're balancing. If you notice, I have to change this number right over here now to get 6 sodium, right? So good thing to use an eraser. Now I'm going to put a 6 over here. So now I don't have 2 sodium, but 6 sodiums. All right. Last one is aluminum. Notice I've got 2 aluminum over here. I need 2 aluminum over there, so I'm just going to put a 2 over there. I could put a 1 here. It's kind of a understood one, so I don't really need to write that at all. Okay, so I've got 2 aluminum, 3 sodium sulfides, 1 aluminum sulfide, and 6 sodiums, and that is a balanced equation. As you get better at this, you may not need to write all those numbers down. Okay, if you want to move on to part 2 of balancing, you can do that now if you want. And I'll leave you with a little joke here. The joke is, why was the mad scientist bad at stoichiometry? He was imbalanced. Ha ha ha. What that refers to is obviously you can't do stoichiometry with an imbalanced reaction. Okay? All right, well, that does it for me. That was part one of balancing. Again, there is a part two. Make sure you watch that. Okay? See you later.